In this video, I will tell you what is unilateral Laplace transform. We know that Laplace transform varies from minus infinity to infinity. Then as the name suggests for unilateral Laplace transform, the integral varies only in unidirectional, that is 0 to infinity. The equation of Laplace transform is given as Laplace transform of x of t is equal to integral minus infinity to infinity x of t e raised to minus st dt. It is also called as bilateral Laplace transform. Unilateral Laplace transform of x of t is equal to integral 0 to infinity x of t e raised to minus st dt. Let us consider one problem in order to understand the concept of unilateral Laplace transform. So the problem given here is find the Laplace transform and unilateral Laplace transform of u of t plus 1 plus u of t minus 4. Applying the Laplace transform on the given signal individually, we get integral minus infinity to infinity u of t plus 1 e raised to minus st dt plus integral minus infinity to infinity u of t minus 4 e raised to minus st dt. Now, for the first integral, we have u of t plus 1 term which is varying from minus 1 to infinity having a value equal to 1. For t less than minus 1, u of t plus 1 is equal to 0. So we are changing the limits of the integral from minus 1 to infinity e raised to minus st dt. Plus for the second term, we have u of t minus 4 term. So this term is having a value equal to 1 starting from 4 to infinity. So we are changing the limits of the integral from 4 to infinity e raised to minus st dt. Solving the integral, we get e raised to minus st divided by minus s for the limits minus 1 to infinity. Plus for the second integral, we get e raised to minus st divided by minus s for the limits 4 to infinity. So when we substitute t is equal to infinity, we get e raised to infinity that is equal to 0 minus when we substitute t is equal to minus 1, we get e raised to s divided by minus s. So we get our answer plus e raised to s divided by s. For the second term, again when we substitute e raised to infinity, the answer is equal to 0. And when we substitute t is equal to 4, we get plus e raised to minus 4s divided by s. So the total answer for the given signal is e raised to s plus e raised to minus 4s divided by s. The region of convergence is real of s greater than 0. Let us solve now unilateral Laplace transform. For the first term, u of t plus 1, though we know that this term is having a value equal to 1 from minus 1 to infinity, we know that unilateral Laplace transform is varying over 0 to infinity. So we write integral 0 to infinity e raised to minus st dt plus for the second term we have integral 4 to infinity e raised to minus st dt. Solving the integral, we get e raised to minus st divided by minus s over the limits 0 to infinity. Plus, for the second term, we get e raised to minus st divided by minus s for the limits 4 to infinity. So, substituting the values of the limits, we have e raised to infinity that is equal to 0 plus when we substitute t is equal to 0, we get e raised to 0 that is equal to 1. So we have 1 divided by s plus for the second term when we substitute e raised to infinity again we are getting equal to 0. When we substitute t is equal to 4 we get e raised to minus 4s divided by s. So the final answer is 1 plus e raised to minus 4s divided by s. The region of convergence is real of s greater than 0. So you can see that for the same region of convergence, we are getting a different answer for Laplace transform and for unilateral Laplace transform. So always check the question properly before solving the problem. Thank you.